This is a video for the top of section 3 of your Unit 10 volume flipbook. Again, I'm fighting a cold, and you've probably noticed that from all my videos in this unit, but bear with me if you could, and we'll make it through this together. Alright, so the top of section 3. There's two subjects I want to cover in this section. The first is, what is a cross section? So the essential question is, what is a cross section? And if you look at these two diagrams, class, you can see we've got, let's see if I can get my marker pen up here. We've got a cylinder and we've got a rectangular prism. And notice there's a plane, this bottom shape here, there's a plane that's just sitting here on the bottom of the base, or right at the base of both of these shapes. And you can see there's another plane that is cutting across these two objects, the cylinder and this rectangular prism. What I want you to get from this is that, first of all, the definition of a cross section. The cross section of an object is a piece which is cut out by a plane. So if you look at this, if we kind of took a really thin blade and we sliced across this cylinder, you can take a tiny little slice right out of the middle of this. Same thing for the rectangular prism. You can take a tiny slice out of this. This is called a cross section, and it can be taken all different ways. We can take a cross section this direction. We can just take a corner of this shape out, take a cross section out of there. So a cross section is just a slice or a piece that is sliced out of an object. Now, the thing that I want to get from this is, and that's the second part here, a cross section cut out of a prism or cylinder which is parallel to a base will be congruent to the base. So if I had this plane that was sitting right here parallel to my base, and I slid that plane up, part way up, and then right at where that plane was cutting through our shapes, I just took that slice out of there. This slice right here is going to be congruent. It's going to be congruent to the base. And the same thing from this rectangular prism. If this was my base, if I decided that was going to be my base, then this slice that is cut out by a plane which is parallel to the base is going to cut a slice out that is congruent to the base, the exact same size as the base. So that covers the basics of what a cross section is. Second part for the essential question, new essential question: how do I find the volume of an oblique object? And let's define oblique. It actually just means it's crooked or slanted. So take a look at these two rectangular prisms, class. One of them is called a right rectangular prism, and that's because these edges that are coming up from the base, if we call this our base, then all these edges that are coming up from the base to attach the other base, they all meet the base at a right angle. That's not true of an oblique rectangular prism. An oblique rectangular prism is kind of like the Leaning Tower of Pisa. It's kind of tilted off to the side. Let's go ahead and label a couple things here. Let's make sure we note that these are prisms. We know that. Oops. That's really messy. Let's fix that. Okay, these are prisms. And we can go ahead and label. Let's label the height of this one. It's this distance right here. There's our height. We know that height is going to be the distance between the two bases. If I call this my base, this is my opposite base, height is the distance between them. The difference with an oblique rectangular prism is now the height is still the distance between the two bases, only now you can't measure it along an edge like you do here. You actually have to just take your ruler and set it at the bottom of the base and go straight up perpendicular from the base, and that's where you would find your height. So it's a little bit more difficult to find the height of an oblique object because you can't just put your ruler up against this edge. That's going to give you a false height. Remember how we measure our own height from the ground? You got to measure straight up to get your actual height. With an oblique object, it's the same thing. You must measure straight up from the ground. That's why this says a right angle right here. It's straight up from the ground. All right, now the same principle is going to apply to cylinders. We've already figured out, we know how on a right cylinder, again, we know it's a right cylinder because this edge or your lateral surfaces are right at a right angle to the base. And let's go ahead and highlight our base. This is a right angle. This cylinder stands straight up and down. So we know the height's going to be the distance between the two bases. So what happens if we get an oblique cylinder? It's crooked just like the oblique rectangular prism, but the same thing applies. You're going to measure the height as the distance between the two bases, and that's going to be our height. You're not going to measure along this edge right here. You're going to measure from the ground straight up, or from the base straight up, just like again you would measure your own height. Now when you do that, when you measure height this way for an oblique object, the cool part is volume is found the exact same way. So here's your text to write down. The volume of an oblique or slanted object is found the same way as a right object, as long as you think of the height as the perpendicular distance between the two bases. This is known as Cavalier's principle. I will show you an example of that in class, of how that works, so that makes a little more sense to you. But it's kind of cool. I can take this same cylinder, and instead of having it go straight up and down at a right angle, I can squish it over to the side really crazy at a big angle, and the volume is exactly the same, and it's calculated exactly the same way. Again, as long as you don't measure the height as the length here, this slant height, you measure the height from the ground or the bottom of the base perpendicular up to the opposite base. So the distance between the two bases is your height.